Welcome back to Math with Rhyme or Reason. Today I want to talk about multiplying and dividing when things are under different kinds of radicals. That is, you might have a square root and a cube root and you have to multiply them or divide them. Now there's two ways to present answers usually with this. There's complete radical form, or in one radical, and there's simplest fractional form. So I'll do most of the answers both ways. Before we get started, though, I need to remind you of an exponent law that you probably learned way back in grade 9, but we're going to use it quite a lot today, so I'm going to just put it in the forefront to remind you. And that is that you can write radicals and fractionals in, they mean the same thing. So for example, if I was taking, let's start with something simple, like the square root of x times the cube root of x, I can change everything into fractional exponents, that is, x to the 1/2 times x to the 1/3, watching where my numbers go, okay? Now, because my bases are the same, I can add the exponents because I'm multiplying. But remember, when you're adding fractions, that you need a common denominator. So this would be the same as saying x to the 3/6 plus 2/6, because I'm changing both of them to 6, my common denominator, which would give me x to the 5/6. That's your answer in simplest fractional form. If you were writing it in radical form, using this law again, but in reverse, again, pay attention to where the numerator goes and where the denominator goes in the fraction as far as where it goes with the radicals. So there's a nice simple form of multiplying with different radicals. Dividing them gets tricky too because you have to worry about not having a radical in your denominator. So let's do one of those. So if we keep it quite simple, let's say the square root of 2x divided by the cube root of, we'll say 4x. Okay, the first thing is they are in different radicals, but the first thing is we can't have square roots in the denominator, so we're going to have to rationalize the denominator. While I'm doing that, I'm noticing that 4 is the same thing as 2 squared. Since I'm going to need common bases as much as possible, I'm going to rewrite this, and I'll just do it down here so you can see what I'm thinking, as 2 squared x. That way, when I'm multiplying to get rid of my denominator, that is, when I'm giving it enough friends to break somebody out, I can multiply by the cube root of 2x squared, because now we'll have 3 2's and 3 x's, so that will get me my 2 and my x out of jail. I need to make sure I multiply by 1, so I'm going to multiply the top also by 2x squared, all cube rooted. Now we have to get everybody into fractional exponents if we're going to write this as a single radical. So I'm just going to erase this. I'm going to rewrite then this in fractional exponents, so that'll be 2 to the 1/2, x to the 1/2. And this one will be 2 to the 1/3 and x to the 2/3. Okay, now I can combine my numerators because we have bases that are the same, the 2's and the x's. So we need common denominators with the 2's, which I'm going to choose 6. So that'll be 2 to the 3/6. Plus 2/6. Same idea with the x's, and again I'm going to use 6 as my common denominator, so that'll give me 3/6 plus 4/6. My denominator is still 2x. And now I can combine things. So I'll have 2 to the 5/6 in my numerator and x to the 7/6 all over 2x. If you want things in simplest fractional form or simplest radical form, either one, I can simplify the x's because I have more x's in my numerator. But if I simplify the 2's, I will end up with a square root in my denominator, which I don't want. So there's a couple ways you can do this. You can now say this is all the 6th root of 2 to the 5th, x to the 7th, over 2x. And then you can pull out the x out of jail. So you would have x, 6th root of 2 to the 5th. You'll still have an extra x left. And then 2x. And now these x's can simplify. So your final answer would be the 6th root of 2 to the 5th, x over 2. That's probably the easiest way to deal with it. You could have also subtracted the exponents here if you get common denominators again. So you could have done x to the 7/6 minus 6/6, which would leave 1/6 in your numerator, and that will end you up in the same place exactly as this. But again, you don't want to simplify the 2's and have a negative exponent or have an exponent in your denominator, because then again, you're having square roots in your denominator, because exponents and square roots are the same thing, but you're not allowed to have radicals in the denominator. So either way, you should end up with that as your final answer. Let's do another one of those. These get complicated, I get it. So let's try again. So let's choose the cube root of 9x and the square root of 3x. Okay, once again, I'm noticing that this is a power of the other. Now, that's not always true, but I'm choosing that on purpose to make it a little easier to work with when I have to simplify things. So in this case, I need to, again, get rid of the square root in the denominator. So I'm going to multiply top and bottom by the square root of 3x. Okay, so that lets the 3x break out of jail. My denominator looks good now. All right, and at the same time, I'm going to change my numerator into fractional exponents. Again, I'm thinking about this being 3 squared. So this in fractional exponents would be 3 to the 2/3, and then x to the 1/3. And this will be 3 to the 1/2, and x to the 1/2. Okay? Again, now all my bases are the same, so I can get common denominators and add the exponents. So I would have 3 to the 4/6 plus 3/6, and x to the 2/6 plus 3/6, and that's all over 3x. So in this case, I'll have 3 to the 7/6, x to the 5/6, and my 3x in the denominator. Okay, so again, I'm going to go with a single radical form and with simplest fractional form, both. So again, I'll have more 3's in the numerator. That is, if I subtract my exponents, I'll have a 3 to the 1/6 in the numerator. So that would give me, I'll do it both ways again so you can see it, but that would give me 3 to the 1/6. And I'm going to leave the x's alone. because again, I don't want to end up with the square root in the denominator. So my numerator would be 3x to the 5th and x. Now with fractional exponents, if your teacher doesn't care about the negative exponents, you could go ahead and simplify this and you would have 3 to the 1/6 over x to the 1/6. You could do that and you end up back where you started, but like I said, the problem with that is you're ending up with a radical in the denominator. Not okay. You're going to end up back where we are. Okay? All right, let's do one more multiplication, and then I'm going to do some more multiplication and division, just a whole bunch of examples in the next video as well. But I'm going to do one more of these, and then we'll let you practice some in your homework first. So we'll do another multiplication. Let's do the square root of 2x plus 3 and the cube root of 2x plus 4. Okay, so we have some foiling to do here, and we have different exponents. We have a whole lot going on in this question. I think it would be smartest for us just to switch everyone into fractional exponents straight away. So this one's going to be 2 to the 1/2, x to the 1/2 plus 3. All I'm doing is rewriting the question. 2 to the 1/3, x to the 1/3 plus 4. All right, so when I multiply these ones, then that's going to be where I have to get common denominators like I did in the previous example. So I'm going to put everyone into sixths. In both cases, that'll be 2 to the 3/6 plus 2/6. So that'll be 2 to the 5/6. Similarly, x to the 5/6. All right. When you're multiplying these, you can't simplify anything. You're going to have 3 times 2 to the 1/3, x to the 1/3. This guy, we can switch him though. We can make him into a 2 squared. So now when I'm multiplying those, I can have a common base and therefore add my exponents. So I'll have 2 to the 1/2 times, 2 squared times 2 to the 1/2, which will be 2 to the 5/2, x to the 1/2, and then I end up with my last two, which is 12. All right, that looks pretty messy, but here we go. So if we're going to get everything in just in terms of radicals, this would be 2x 6th root. 2 to the 5th, x to the 5th, plus these guys are in the radical, this guy is outside, so I'm going to go like this. These guys are both in the square root, but he can break out. So we'll do this in 2 steps. So that would be 2 to the 5th and x, and then 12. Now the only thing I would change, like I said, is this one. I can break 2 of those 2's out. So I'm going to do that, and that will be a 4 out here, because that was 2 squared times the extra 2. So that would be your final answer. Like I said, this gets really messy really quickly. But it gives you a little bit of practice. The big key is you have to be fluent at converting between fractional exponents and radicals. And you have to really know your exponent laws as far as adding and subtracting. You also need to know your fraction laws, make sure you get common denominators and that sort of thing. In the next video, I'm just going to do a couple more examples so you can see a bunch more multiplying and dividing. And then in the final video, we'll start solving some of the equations that have radicals involved. See you soon.